Hi everyone, in this video we are going to solve Cambridge O-Levels Additional Mathematics Paper 2 in a session May-June 2020 Paper 2-1. So let's start with the first question. Question number 1. Variables x and y are such that when fourth root of y is plotted against 1 by x, a straight line graph passing through the points this and this is obtained. Find y as a function of x. Okay, so if I can say that this is capital Y and 1 by x as a capital X. So equation of straight line is y equals to mx plus b or c. We can take any variable. So m is the slope. So let me solve for m. M is y2 minus y1 over x2 minus x1, y2 minus y1. So y2 is 34 minus y1 is 9 divides x2 is 3 minus x1 is 0.5. Right. So let's do it. 34 subtract 9. This is 25 divides 3 minus 0.5. 2.5. 25 divides 2.5 is 10. So the slope is 10. So just substitute 10. Y equals to 10x plus b. And to get the value for y-intercept, you can substitute the first or the second point. This is the x and this is the y. So let's do it. Y is 9 equals to 10. You can substitute the second point as well. X is 0.5 plus b, right? And the b value from here, we have b equals to 9 minus 10 times 0.5. 10 times 0.5. 9 subtract 5 is 4. So the b is 4, the y-intercept is 4, right? So we have the equation now is y equals to 10x plus 4. Now let me substitute the variables x and y back. So capital Y is fourth root of y is equals to 10. This capital X is 1 over x plus 4. And we have to find y as a function of x, but we have fourth root of y. So this y power is 1 by 4. So taking power 4 on both sides. So y equals to 10 by x plus 4 and its whole power is 4. So this is y as a function of x. Right. Now for question number 2 in A part, write this quadratic expression in the form of this where p, q and r are constant. So the standard form of a quadratic equation, we have to write it as a vertex form, converting standard form to vertex form. Okay, so in the first step we have to take the coefficient of x square common from the first term and the second term. So let's take 9 common. We have x square here, and from 12 take 9 common. So dividing by 9, so 12 divides 9 is 4 by 3. So minus 4x divides 3 and plus 5 is outside. So we now in the next step we have to pick the coefficient of x, that is minus 4 divides 3 divided by 2. So this is minus 4 by 3 times we have 2 by 1 or 1 by 2. It's the reciprocal. 2 times 1 is 2, 2 times 2 is 4, that is minus 2 by 3. Right, now taking its square, and its square is equals to 4 by 9. So add 4 by 9 and subtract 4 by 9 inside the bracket, right? X square minus 4 by 3x, adding 4 by 9 and subtracting 4 by 9, and then plus 5. Right, now combine the first three term and take the third term outside. 9 is outside. X square minus 4x over 3 plus 4 by 9, the first three terms, plus 9 is multiplying with minus 4 by 9 and plus 5, right? So from here you can see we can cancel 9 and 9, and 5 minus 4 is just 1. Okay, so 9, and we have x square, and this is 2 square and 3 square, and we have a negative sign. So x minus 2 by 3 whole square and plus 1. right? So we have P, Q, R are the constants. We have converted the standard form to vertex form. Now for part B, hence write down the coordinates of the minimum point of the curve. Okay, so this is the standard form. The vertex form is A into x minus r whole square plus k, right? And um, the vertex of the quadratic equation is rk, right? So what is rk? So 2 by 3 and 1. So in our case we have 2 by 3 and 1. So the minimum point is 1 at x is equals to 2 by 3. Now question number 3, do not use a calculator in this question. We have given the polynomial p of x, a cubic polynomial. For a part, find the remainder when p of x is divided by x plus 1. Okay, so remainder, it means we need to find p of minus 1. So what is p of minus 1? That is 15 minus 1 cube is minus 1 plus 22 minus 1 square is just 1 minus 15 times minus 1 plus 2. This is minus 15 plus 22 plus 15 and plus 2. So plus 15 and minus 15 is 0. 22 plus 2, this is 24. So the remainder is 24 when p of x is divided by x plus 1, right? Okay, now for part B, in the first show that x plus 2 is a factor of p of x. So if x plus 2 is a factor of p of x, it means p of minus 2 must be equals to 0. So let me find p of minus 2 if it is a factor. So 15 minus 2 cube plus 22 minus 2 square minus 15 times minus 2 plus 2, right? So this is 15 minus 2 cube is minus 8 plus 22 minus 2 square is 4 plus 2 times 15 is equals to 30 plus 2, right? Okay, so 15 times 8, 15 times 8, 5 times 8 is 40, 8 times 1 is 8, 9, 10, 11, 12, 120 minus 120. 4 times 2 is 8, 4 times 2 is 8, plus 30 plus 2, right? So let's see, is it equals to 0? So 88 plus 30 plus 2. Let me add this and subtract with 120. So let me do this first. 88, 30 and 2. So 8, 9, 10, 1 and 0. 8, 9, 10, 11, 12, 120. So as you can see, the sum of these three terms are 120 and then minus 120. This all equals to 0. So we have showed that x plus 2 is a factor of the polynomial p of x, right? Now for the second part, write p of x as a product of linear factors, right? So we have the polynomial p of x. This is equals to 15x cube plus 22x square minus 15x plus 2, and we have given the one factor we just saw from the first part, that is x plus 2 is a factor. So we can use a synthetic division to find the rest of the two factors, right? So let's do it. Okay. So let me write down the coefficients of x cube is 15. The coefficient of x square is 22. The coefficient of x is minus 15 and the constant term is 2 and minus 2. Okay. Bring 15 down. 2 times of 15 is minus 30. And from 30 take away 22 is minus 8. And 2 times 8 is 16. And we have 1 here, and 2 times 1 is 2, minus 2, and we have 0. So these are the coefficients for quadratic equation, right? So we can say p of x is now x plus 2 into x 15 is a coefficient of x square. This minus 8 is a coefficient of x, and 1 is a constant term, right? Now let me find the factors for this quadratic expression. So let me factorize this. 15x square minus 8x plus 1. So we have, we can say that 15 times 1 is 15. and 3 times 5 is 15, minus 3 minus 5 is minus 8. Yes, 15x square minus 3x minus 5x plus 1. Taking 3x common. 3 times 5 is 15x minus 1. Taking minus 1 common, 5x minus 1. So the factor is 5x minus 1 and 3x minus 1, right? So we can say that the polynomial p of x as a linear factor, the first factor is x plus 2, another is 5x minus 1, and the next is 3x minus 1. So we wrote down the polynomial p of x as a product of linear factors, so 3 linear factors. Question number 4 in A part. In an examination, candidates must select 2 questions from the 5 questions in section A. Okay, section A has total 5 questions and they can select 2 questions, and select 4 questions from 8 questions in section B. Find the number of ways in which this can be done. Okay, section A has total 5 questions and out of 2 times section B has 8 questions out of 4, right? So let's simplify. We have 5 C2 is 10 times 8C4. 8C4 is 70. 10 times 70 is 700. So this can be done in 700 ways. Now for part B, the digits of the number are to be arranged so that the resulting 7-digit number is even. Find the number of ways in which this can be done. So this is a 7-digit number. 1, 2, 3, 4, 5, 6, 7. Yes. 1, 2, 3, 4, 5, 6, 7. Okay, if the number is even, it means it must end at the even number, even digit, right? So how many digits are even? 6 is an even digit, 3, 7, 8 is even, 2 is even. So 3 digits are even. So we have 3 options for the last digit. It can be 2, it can be 8, it can be 6, right? So let me select 6. Okay, how many options are left? 1, 2, 3, 4, 5, 6. 6 options are left for the first digit, and then 5 are left, and then 4 are left, and then 3, and then 2, and then 1. So let me multiply all of them. Okay, so we have 6 times, 5 times, 4 times, 3 times, 3 times, 2 times 1. This is 2160. Question number 5, the vectors a and b are such that a equals to this and b equals to this. For a part, find the value of each of the constants alpha and beta such that 4a minus b equals to this. Okay, so let me substitute the vector a and b over here. So 4 times of a is alpha I unit vector plus j unit vector minus the b is 12i plus beta j. And this is equals to alpha plus 3 into I minus 2j, right? So let me simplify this. So 4 alpha I plus 4j minus 12i minus beta j. This is equals to alpha plus 3 into I minus 2 into j. Okay, let me simplify the I unit vector. So we have 4 alpha minus 12. This is for I unit vector, and for j, we have 4 minus beta for j. This is equals to alpha plus 3 I and minus 2 j. Okay, so now let me compare the I unit vector and the j unit vector, right? Okay, so if I compare the I unit vector, this component equals to this. So 4 alpha minus 12 equals to alpha plus 3, right? So shift the alpha over here and we have 4 alpha minus alpha equals to 3 plus 12. So 3 alpha equals to 3 plus 12 is 15, and 3 times 5 is 15. Alpha equals to 5. So we got the value for alpha. Now on the same steps, we need to compare j unit vector. This equals to this. Okay, so my 4 minus beta equals to minus 2, and 4 plus 2, this is equals to beta, and this is equals to 6. So alpha is 5 and beta equals to 6. Now for part B, hence find the unit vector in the direction of b minus 4a. Okay, now let me write down the a and b. So a we got is alpha I plus j. So alpha is 5i plus j is a vector a, and the vector b is 12i plus beta j, that is 6j. Okay, so we need to find the unit vector in the direction of this. So let me find b minus 4a. This is 12i plus 6j is the b, minus 4 times the vector a is 5i plus j. So this is 12i plus 6j. 5 times 4 is 20j minus 4j. Okay, so 20 subtract 12. So this is equals to 8, negative of 8i. So this is I unit vector, right? And j, 6 minus 4 is 2, j. So this is a vector b minus 4a, right? So we need to find the unit vector in this direction. It means vector divide its magnitude. Now let me find the magnitude of b minus 4a. That is square root of 8 square is 64 and 2 square is 4. So 64 plus 4 is square root of 68. Okay, so the unit vector we can say is vector divide its magnitude. So this is a vector minus 8i plus 2j divides the magnitude, that is square root of 68. So this is a unit vector in the direction of this, right? Question number 6, find the values of k for which the line and the curve do not intersect. Okay, so on what values of k the line and the curve do not intersect? So let's find the values of k. So first we need to equate the y. So we have 3x square plus 8x plus 5, put it equals to kx minus 7, and 3x square plus 8x minus kx plus 5 plus 7 equals to 0. So 3x square, taking x common, so we have 8 minus k is a coefficient of x, and 5 plus 7 is 12. This is equals to 0. So we okay, so now this is a quadratic equation. We need to find the values of k when the line and curve do not intersect, right? If they intersect at one point, it means the discriminant is equals to 0. If they intersect at 2 points, the discriminant is greater than 0. And if they do not intersect, the discriminant is less than 0. So we have to use discriminant method. Discriminant is b square minus 4ac, and that must be less than 0 for the complex roots when it do not intersect, right? So this is a b, the x coefficient is b, the x square coefficient is a, and the constant term is 12. Okay, now let me substitute the value. The b is 8 minus k whole square minus 4, a value is 3, and the c value is 12, right? Now let me simplify this. So this is 8 square is 64 minus 2 times 8 is 16k plus k square, and let me solve this. 4 times 3 times 12, this is minus 144. Now we have k square minus 16k and 64 minus 144, this is minus 80. So we have a quadratic equation in k. We have to find the roots. So this is 80, and we can say that 4 times 20 is 80. Yes, 4 times 20 is 80, and 4 minus 20 is negative of 16. Let's break the midterm. So k square plus 4k minus 20k minus 80. So from here, let me take k common. We have k plus 4 and minus 20 is common, k plus 4, right? 20 times 4 is 80. 20 times 4, yes. So the two factors are k plus 4 and k minus 20. Right, now we have the two values for k. K equals to minus 4 and k equals to 20. Right. Okay, so let me draw this curve on the coordinate plane. Okay, so as you can see, we have a quadratic equation in k, and the k square coefficient is positive. It means the parabola opens upward, right? Okay, and we have the two roots, minus 4 and 20. Let's say minus 4 is over here and we have 20 over here, right? So this is going to be the shape of the parabola. Right, now we have to find the points when the discriminant is less than 0. So when this curve is less than 0, when it is between minus 4 and 20, it is less than 0. So we can say that when the k value is between minus 4 and 20, the curve and the line do not intersect. Question number 7 in part A, solve the simultaneous equations giving x and y in exact simplified form. Okay, so we have 10 exponent this and 10 exponent this. So we can take convert this is the exponential form into logarithmic form with the base 10. So for the first equation, we have x plus 2y. We will get log base 10 5, right? And from the second equation, we will get 3x plus 4y equals to log base 10 50, right? Okay, now let me solve the values for x and y. So this is my equation 1. So from here we can say x equals to log 5 minus 2y. Right, let me substitute this x over here. So we have 3 times of x value is log 5 minus 2y plus 4y equals to log 50. So 3 log 5 minus 6y, 3 times 2, plus 4y equals to log 50. Right. So we have minus 2y is over here, and we have log 50 and minus log 5 cube, right? Now to solve for y, we have minus 2y equals to log of 50 divides, what is 5 cube? 125, 125, right? And we have 5 divides 125 is 1 by 25, right? So we can say minus 2y equals to log of 1 over 25, right? Let me open this. So here we have 50 over 125. 50 divides 125 is 2 by 5. Sorry, this is 2 by 5. Okay, and to solve for y, we need to divide by 1 by 2. So we can say y equals to minus 1 divides 2 log of 2 by 5, right? And to get rid of this minus sign, we can say 1 by 2 log of 2 by 5 power is minus 1, and y equals to 1 by 2 log of 5 by 2. Just taking a reciprocal because its power is minus 1, right? Okay, so this is a y value. To solve the x value, we have to substitute this y value into this equation. So we have x equals to log 5 minus 2 times of this. That is equals to 1 by 2 log 5 by 2. Okay, so we can cancel the 2 and 2. So we have log this minus log this. So we have to, when we have a subtraction, we can divide the logs, right? So here we have log 5 divides 5 by 2, right? So we can say 5 is cancelled with 5, so you are just left with log 2. This is x value is log 2 and the y value is 1 by 2 log 5 by 2, right? Now for b part, solve this equation. Okay, so let me substitute here. Let us suppose that u equals to x exponent 1 by 3, right? So we have 2, and if we take the power 2, we have u square minus u minus 10 equals to 0, right? And now we have a factor. 2 times 10 is 20 and 5 times 4 is 20 and minus 5 plus 4 is equals to 1. U square minus 4u plus 5u equal minus 10 equals to 0. 2 times 10 is 20. 4 times 5 is 20. 5 minus 4 is, no, this is plus and this is minus to get minus 1. 2u is common. We have u plus 2 minus 5 is common, u plus 2. 5 times 2 is 10 equals to 0. So the two factors are u plus 2 and 2u minus 5 equals to 0, right? Let me get the value for u and substitute x equals to 1 by 3 at the end. So here we have u equals to minus 2 and u equals to 5 by 2. Right, or we can say x power 1 by 3 equals to minus 2 and x power 1 by 3 equals to 5 divides 2. And to solve the value for x, we have to do cubes on both sides. We have a power 3 on both sides. We have x here, and 2 power 3 is minus 2 power 3 is minus 8. And here we have x, and 5 power 3 is 125 and 2 power 3 is again 8. So the two values of x are minus 8 and 125 by 8. Question number 8, part A, expand this expression simplifying each coefficient. Okay, so we have to apply the binomial expansion here. So the first term exponent is 5 plus 5c1. The first term exponent is 4 and the second term exponent is 1 plus 5c2. First term exponent is 5, 4 is 3 and the second term exponent is 1 and now it's 2 plus 5c3. First term exponent is 2 and second term exponent is 3 plus 5c4. First term exponent is 1 and the second term exponent is 4 and the last term is plus 5c5. First term is 0 and the second term exponent is 5. Okay, so 2 exponent 5 is 32. Yes, so we have 32. What is 5c1? 5c1 is 5. 2 exponent 4 is 16 and minus x. Okay, 5c2 is 10. This is 10. 2 cube is 8 and x square. 5c3. 5c3 is equals to 10. 2 square is 4 and minus x cube. 5c4 is 5 times 2 and x power 4, right? 5c5 is just 1 and 2 exponent 0 is also 1 and this is just minus x power 5. Okay, let me simplify this. So we have 32. 5 times of 16 is minus 80x, right? And 10 times 8 is 80 plus 80 x square. 10 times 4 is 40 x cube. 5 times 2 is 10 x power 4 and minus x power 5. So this is a we have simplified it each coefficient. Now for part B, hence solve this equation. Okay, so let me simplify all the terms. Okay, so e power 2 minus x exponent is 5 times e power 80x, and here we have times e power minus 10x4 minus 32 equals to e power minus x power 5, right? Okay, now we have bases are same, just adding the powers. So 2 minus x whole exponent is 5 plus 80x, right? And minus 10x power 4 minus 32. This is e power minus 5, x minus x power 5, right? Now we can compare, the bases are same, e and e, we can compare the exponents. Okay, so here we have to compare exponent. 2 minus x whole exponent is 5 plus 80x minus 10x power 4 minus 32 equals to minus x power 5, right? So we did this in a part. 2 minus x exponent 5, yes, this is equals to this. So let me write this down. So we have 32 minus 80x plus 80x square minus 40x cube plus 10x power 4 minus x power 5. Okay, so now plus 80x, this minus 10x power 4 minus 32 equals to minus x power 5, right? Now let me cancel the like terms. Minus 32 plus 32 minus 10 power 10 x power 4 plus 10x power 4 and 80x and minus 80x, right? So now we have 80x square minus 40x cube, and shifting this here, we can cancel these two as well on both sides. We will get just this equals to 0, right? So let me take 40 is common and x square is common, right? And 80 divides 40 is 2. So 2 is left and minus x is left equals to 0, right? So we have to put 40 x squared equals to 0 and 2 minus x equals to 0, and from here x value equals to 0 because 0 divides 40 is 0 and square root of 0 is 0, and from here x value equals to 2. So this is minus 2, and cancelling the values we have 2. So we have two values for x equals to 0 and x is equals to 2. Question number 9. A particle travels in a straight line as it passes through the fixed point O. The particle is traveling at a velocity of 3 meter per second. The particle continue at this velocity for 60 seconds and then decelerate at a constant rate for 15 seconds. To the velocity of 1.5 meter per second. The particle then decelerate again at a constant rate for 5 seconds to reach point A, where it stops. Now for A part, sketch the velocity time graph for this journey on the axis below. So we have given the velocity time axis. We need to sketch this graph. Okay. So the particle travels in a straight line. So it's a straight line as it passes through a fixed point O. So this is a fixed point O. The particle is traveling at a velocity of 3 meter per second. So this is a velocity that is 3 meter per second in a straight line, right? Okay, so let me do for 3 meter per second, if I can say this is okay. So this is 1, this is 2, and let's say this is 3, right? So this is 3 meter per second. For the particle continue at this velocity for 60 seconds. Okay, so 60 seconds, we have given this information. The time is 60 seconds. Okay. So here we have 60, 70, 80, and 50, 40, 30, 20, and 10, right? So this is a 60 seconds, right? So for 3 travels in a straight line, this, right, for 60 seconds. Okay, now the next is then decelerate at a constant rate for 15 seconds to a velocity of 1.6 meter per second. Now decelerate, right? At a constant rate, it decelerate and for 15 seconds. So 60, 70, 75. Next 15 seconds, right, at 75, and the velocity is 1.6. So this is 0 0.5, 1, this is 1.5, 2, this is 2.5, right? So 1.6 is somewhere over here, right? Okay, and it decelerate at this point. So let me do maybe this point. Let me check. Right. Right. Okay, and the next we have given the information, the particle then decelerate again at a constant rate for 5 seconds. It decelerate again for 5 seconds. So this is 80, 75 to 80, the 5 seconds to reach the point A where it stops. So it stops at 80. Right. So this is the point 75. Time is 75 here and the time is 60 here, right? So this is a sketch of the velocity time graph for this journey on the axis. Now for part B, find the distance between O and A. So this is the point O and this is a point A. So distance traveled for the velocity time graph is area under the curve, right? So we have to find area under the curve. So let me draw this line. So as you can see, these are the two parallel side and these are the two parallel side. So these are the two shapes. We need to find the area for this and this shape. So these two look like a trapezium. So this is a trapezium and this is for the trapezium, right? So area for this trapezium is half the sum of parallel side times height. So the area for this trapezium is half sum of the parallel side. So this side is from 0 to 75 plus this is 0 to 60 times height is 3 to 1.6. Okay, so 3 subtract 1.6, this is 1.4, right? So let me simplify the first area. 75 plus 60 divides 2 times 1.4. This area is equals to 94.5, right? Now let me calculate the second one. So this area, right, the area of this trapezium, these are the two parallel side and this whole shape is a trapezium, right? So area for the second trapezium we can say is again half the sum of parallel side. This is from 0 to 80, this is from 0 to 75. So this is 75 plus 80 times the height. So this is the height 0 to 1.6. Right. So let me do this. 75 plus 80, right? And divides 2 times 1.6, 124. Now adding the two, 124 plus 94.5. So this is 218.5 meters is the distance traveled. So we can say that the distance between the point O to A is 218.5 meters. right? Now for part C, find the deceleration in the last 5 seconds. Okay, so these are the last 5 seconds, 75 to 80. So deceleration is basically the gradient. We need to find the gradient, right? So gradient is change in y values over change in x value. So what is the y value here? So this is like y value, that is 1.6, and the x value is just 5. So we can say that deceleration is the 1.6 divides 5. So we have, let me do 1.6 divides 5. This is equals to 0.32. 0.32 meter per second scale, right? Question number 10. The diagram shows part of the graphs of this function, yeah, this one, and y equals to this function. The graph of this function meets the x-axis at point A, where x is a and y is 0, and the two graphs intersect at point B, where x is b and y is equals to 4. Okay, so for a part, find the value of a and of b. So that's pretty easy. So as you can see, this curve intersect x-axis at point A. So for x-axis, y component equals to 0. So this curve y equals to x minus 3 whole scale, right? So when x component, you have, sorry, y equals to 0 at x-axis it meets, right, for point A. So it meets x-axis. So y component is 0. So this is x minus 3 equals to 0. So taking square roots on both sides. So square root of 0 is 0. So x minus 3 equals to 0. So x value equals to 3, right? So we can say that the a point, x is 3 and the y is 0. So means this a is equals to 3. So from here a equals to 3. Right, now let me solve for b. So for b, we have given this information that the two curves intersect at this point where x is b and y is 4. So you can substitute x equals x and y values into this curve or this curve. So let me do in the second one. This is easy. So we have y equals to 4 x exponent 2 by 3. Okay, b 4. So y is 4. This is the b exponent 2 by 3. So 4 divides 4 is 1 equals to b exponent 2 by 3. Now taking the powers 3 by 2 on both sides, we have 1 power 3 by 2 and equals to b. So we can say b equals to 1. So a is 3 and b value is 1. So these component of a is 3, 0, right? And here the component is 1, 4. Right, so the x value over here is 1. Let me draw this, right? So this is 1 here, right? So we have 0, 1, and here we have 3. Now for part B, find the area of the shaded region. So this is the shaded region. So I already broke the area. So we need to find area between 0 to 1 and then 1 to 3. Okay, so between 0 to 1, we have to use this curve, right? And for 1 to 3, we have to use this curve, integration of the two curves, right? Okay, so we can say that shaded area equals to integration between 0 to 1. Yes, 0 to 1 of this curve 4x exponent 2 by 3. 4x exponent 2 by 3 dx plus integration between 1 to 3. X is between 1 to 3 for the second curve, that is x minus 3 whole scale. X minus 3 whole scale dx. Okay, let me simplify this. We have 4 and we have to use a power rule over here. So x power 2 by 3 plus 1 divides 2 by 3 plus 1, and the limits we have to substitute from 0 to 1, plus again a power rule, x minus 3 power is n plus 1, 2 plus 1 divides 2 plus 1, and the limits are between 1 to 3. right? So here we have 4x exponent, what is 2 by 3 plus 1? 2 divides 3 plus 1, this is 5 by 3. 5 by 3 divides 5 by 3, and the power is between 0 to 1, plus x minus 3 whole cube over 3, and the power is between 1 to 3, right? So we have 5 by 3, doing a reciprocal for the numerator, we have 4 times 3 by 5, x exponent 5 by 3, 0 to 1, plus x minus 3 whole cube divides 3, 1 to 3. Right, now let me substitute the limits. 4 times 3 is 12. We have 12 by 5. Upper limit is 1. Lower limit is 0. Plus 1 by 3 is outside. Upper limit is 3. 3 minus 3 is 0. And lower limit is 1. Subtract 1 minus 3 whole cube. Right. So this is 12 by 5 plus 1 by 3. We have minus, and 1 minus 3 is equals to minus 2, and minus 2 cube is minus 8, and this minus minus is plus. We have 8, right? Okay, so we have 12 by 5 in the simplest form and plus 8 by 3. So let me simplify this. 12 divides 5 plus 8 divides 3, and this is 76 over 15, or 5.067. Yes, this is equals to 76 over 15. 5.067 is a shaded area. Question number 11. The function f is defined by f of x equals to ln of 2x plus 1 for x is greater than equals to 0. So all the positive x values. For a part, sketch the graph of y equals to f of x, and hence sketch the graph of y equals to f inverse of x on the axis below. So the graph f and f inverse are basically reflection of each other along a line y equals to x, right? So let me sketch this graph, right? And we need to pick the values of x that are 0 or greater than 0, because 0, 1, 2, 3 up to infinity, right? So if x is equals to 0, what is f of x? This is equals to natural log of 2 times 0 is 0, that is 1, and natural log of 1 is equals to 0. So this point we have, right? And when x is equals to 1, we have f of x is equals to natural log of 2 times 1 is 2 plus 1, that is 3. So what is ln 3? Ln of 3 is 1.09 or 1.1, we can say. So this is equals to 1.1. So when x is 1, y is 1. So we have this second point and this. So let me check on one more point. When x is 2, f of x is equals to ln of 2 times 2 is 4 plus 1, that is 5. What is natural log 5? That is 1.6. And when you round it is again 2. So basically same thing. So for 0, 0, 1, 1, 2, 2. So this is going to be the shape of this graph for f of x, right? And for f inverse of x, that is a reflection along a line y equals to x. So let me draw this line. Y equals to x is this line. So it is a reflection. So we will get this curve, right? So this is going to be the curve for f inverse of x. Now for the second part, the function g is defined by g of x equals to this for x is greater than equals to 4. Part B, in first, find an expression for g inverse and state its domain and range. Okay, the function g is given. We need to find g inverse and finding the domain and range for g inverse. So for g inverse, we can say y equals to g of x, that is x minus 4 whole square plus 1, right? And then switching the variables, we have x equals to y minus 4 whole square plus 1, and solving for y. So x minus 1 equals to y minus 4 whole square, and to get rid of the square, taking square root on both sides. So square root of x minus 1 equals to y minus 4. And from here, the y value, or we can say g inverse of x is the y value. Shifting 4 here will become positive 4 plus square root of x minus 1, right? So this is the function g inverse of x, and we have to state the domain and the range for this function. So as we have given that for the function g of x, the domain is x is greater than equals to 4. Now the range of g inverse is, range of g inverse of x is, we can say y, or g inverse we can use, is less than equals to 4, right? The domain of g is the range of g inverse, right? Now the domain of g inverse of x is, as you can see, the function when you put the values of that is greater when all the answers are greater than equals to 4, so it means x is greater than equals to 1. When g inverse is less than equals to 4, so output is less than equals to 4, so input all the values of x that is greater than equals to 1, because we cannot put less than equals to 1. We will get a negative sign inside the square root, and which is undefined. Now for second part, find and simplify an expression for f composition g of x, right? So f of g of x, we have given is x minus 4 whole square plus 1, right? And f of x we have given is natural log of 2 times of this x, that is x minus 4 whole square plus 1. Yes, and this is plus 1 outside, right? And we need to simplify this expression. So this is natural log of 2, opening the square here inside the bracket, x square minus 2 times 4 is 8x plus 16 plus 1, and this term, and then plus 1 is outside, right? So now we have natural log of 2 into x square minus 8x plus 17 plus 1, right? Or ln of 2x square and minus 16x, and what is 2 times of 17? 2 times 17 is 34, and then plus 1, here we have 35. So this is a simplified expression for f composition g of x. Now for the third part, explain why the function f g composition f does not exist. Okay, so let me write down the domain for f of x we have given is x is greater than equals to 0, and the domain for g of x we have given is x is less than equals to 4, right? So here we have f of g, f composition g, and here we have g composition f. So g values are less than 4, 4, 3, 2, 1, 0, minus 1, minus 2, minus 4. But function f of x values are more than 0, 0, 1, 2, 3, 4. So between 0 to 4, it comes into the both are same, but g contain the values that are less than 4. It can be negative values, minus 1, minus 2, minus 3. So we can say that, so this is not possible because the domain of g is outside the domain of f, right? So there is a discontinuity. So we can say that the reason is domain of g of x is outside the domain of f of x, because f of x contain all the values that are more than 0. So g of x contain values that are less than 4. So 4, 3, 2, 1 till 0, because between 0 to 4 that is okay, but the values that are less than 0 are, so g is outside the domain of f. So there is a discontinuity, so that is why g composition f does not exist. Now number 12, in a part, find the x coordinates of the stationary points of the curve. Okay, so to get the stationary point, we have to find the derivative of the curve and put it equals to 0, and solving for x we will get the x coordinates, right? So let me solve the derivative first. So dy by dx, this is equals to the product rule. We have two functions, so we can say the first function e power 3x is as it is, the derivative of this function, that is a power rule. So we have a power, the base function, power minus 1, and the derivative of base function is just 2, plus the second function is as it is, and the derivative of the first function, that is 3 e power 3x, right? So let me simplify again. We have 6 times 2 is 12 e power 3x, and 2x plus 5 power 6, sorry, 2x power 5 and 2x plus 3. Okay, and here we have 3 e power 3x and 2x plus 3 power 6. Okay, for further simplification we can take 3 common, e power 3x is common, and 2x plus 3 power 5 is common, right? So this is common, this is common. 3 times 4 is 12, and we have here is, what is left? 3, and this power is left, plus 2x plus 3, just 1 power is left, right? And 3 e power 3x, 2x plus 3, and we have 2x plus 4, 5, 6, 7, right? So this is the derivative. Now let me find the stationary point. We have 5 here, sorry. Now let me substitute the derivative equals to 0 to get the stationary points. So for the stationary points we can say 3 e power 2x, 2x plus 3 exponent 5 into 2x plus 7 equals to 0, right? So 3 e power 3x, sorry, this is not equals to 0, right? 3 e power 2x is not equals to 0. It means these two factors separately equals to 0. So means 2x plus 3 power 5 equals to 0, and 2x plus 7 power 1 equals to 0, right? So we have a 5 here, so we can use take a fifth root on both sides. 0 fifth root is just 0, so we have 2x plus 3 equals to 0, and from here x value is minus 7 by 2, and here the x value is minus 3 by 2. Or if we convert this into decimals, 7 divides 2 is equals to 3.5. This is negative 3.5, right? The x coordinate of the stationary point, and 3 divides 2 is 1.5, yes, minus 1.5. Part B. A curve has equation y equals to f of x. This is the different curve and has exactly 2 stationary points. Okay, given that the second derivative of the function is 4x minus 7, and the first derivative at 0.5 is 0, and first derivative at 3 is 0. It means 3 and 0.5 are the 2 stationary points. Use the second derivative test to determine the nature of each of the stationary points of this curve. That's easy. So first stationary point, second derivative we have given is 0.5. So we have to check at the first one and for the second point. So to check the nature, we need to put both the stationary points into the second derivative. So 4 times of 0.5 minus 7, and here 4 times of 3 minus 7, right? So 4 times 0.5 subtract 7, that is minus 5. So when it is minus 5, the second derivative is negative, so it means this point is maximum. Okay, so 4 times 3 minus 7 is 5. This is positive, it means this point is minimum. So the nature is maximum and minimum. For 0.5 it's maximum, and for 3 it is minimum. Now for part C, in this question all the lengths are in centimeter. The diagram shows a solid cuboid with a height h and a rectangular base measuring 4x by x. The volume of a cuboid we have given is equals to 40 centimeter cube, and given that x and h can vary, okay, and that the surface area of a cuboid has a minimum value, find that value. Okay, so let's do it step by step. So we have given the volume of a cuboid, and the formula for volume of a cuboid is volume of cuboid has a formula length times width times height, right? So the volume we have given is 40, length is x times 4x times height is h, right? So let me solve the value for h from here. So 40 equals to 4x square h, and from here the h value is 40 over 4x square, or we have 10 by x square is the height, right? Okay, now we need to find the surface area. Surface area of a cuboid, we have 1, 2, 3, 4, 5, 6 faces for the cuboid, right? So let me do the surface area of a cuboid. Okay, so the first face, this, the front and the back, the two same faces. So this is a rectangular, the front is a rectangle, it is 4x by h, right? So this is 2 times of 4x times h plus 2 times of the left and the right face, x times h plus 2 times of the top and the bottom, 4x times x, right? 4x times x. Now we have to use this h value here, right? So here we have 2 times 4 is 8x, and the h value is 10 by x square, 2x, and this is 10 by x square plus 8x square, right? Okay, let me simplify it further. So this is 80, this x is cancelled with x square, we have just x, and we have 20 over x here, and then plus 8x square, right? So let me simplify this. This is 100 over x plus 8x square. Okay, so this is a surface area of the cuboid. Now we have to find the minimum value. So for the minimum value, we know that for minimum or the maximum value, we have to find the derivative of the surface area, ds over dx, and put it equals to 0. We will get the value for x, right? So the derivative for this function we can say is equals to 100 over my 1 by minus 1 over x square, and plus 2 times 8 is 16x equals to 0. Now let me solve for x. So here we have 16x equals to 100 over x square, right? Doing a cross multiplication, x cube equals to 16 over 100. It's 100 over 16. So let me write the simplest form of 100 by 16 is 25 by 4. So this is 25 by 4 is x cube, and to find the value for x we have to do the cube root of 25 by 4. This is the x value. Now we have to substitute this x value back to the surface area of a cuboid, and that would be the minimum value. So now the surface area is 100 over x plus 8x square. So just substitute the x value. This is x value, 100 divides the cube root of 25 by 4 plus 8, the cube root of 25 by 4 whole square, right? So let me simplify this and get the value for x, the minimum value, right? So 25 divides 4, and taking the cube root, the cube root of 25 divides 4 is this, right? And we have 100 divides answer plus 8 answer square. 81.43. Or this, the minimum value of the surface area is 81.4, right? So that was the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.